Okay, we're here with Rita to talk about constant of proportionality. Ready to go?
Yeah.
Okay, so we're going to talk about this in two ways. One is finding from tables, and the other one is finding from graphs. So let's first talk about tables. Before we do that, let's just talk about what the constant of proportionality is. There's some big words, but really what it is, it's about a relationship between x and y, and it's really pretty simple. Let's go ahead and write it right here. The definition of a constant of proportionality is when you have a proportional relationship, it's the number you multiply x by to get y. Okay, so let's see what that means in a table. Let's go ahead and put a table of values here. So if we think about our definition up here, we're going to be multiplying x by something to get y. So you can go ahead and look in these values. We have a bunch of x values here, 0, 1, 2, 3, 4. And each time we're going to be multiplying that x value by the same number to get y. Okay, same number on each row. So can you guess what that number might be?
Yeah, 3.
3. Good. And let's just make sure that that looks true here. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Seems to work, right?
Right.
This first row is a little bit different, huh? 0 times 3 is 0, right? So that doesn't give you too much clue because the constant proportionality could be 10 or 5 million or something, and these two numbers would still be the same. So you're probably going to get most of your clues from these numbers down here. So as you said, the constant proportionality for this one is
3.
Right, so we'll go ahead and write that. Now let's look at a different table. What do you think the constant of proportionality might be here?
Let's see. 0.9.
0.9, good. And how did you get that?
I looked at x equals 1, and then 0.9 is y, so 1 times 0.9 is 0.9.
Good, great trick. So if you look at the one row, it can usually give you what the constant of proportionality is in a proportional relationship. And does that hold true for 2? Does 2 times 0.9 equal 1.8?
Yes.
Okay, and so on with 3 and 4?
Yeah.
Good. So we can write down here the constant of proportionality is 0.9. Great. Okay, now we can also find the constant of proportionality with graphs. So let's go ahead and put up a graph here. Now, what we're looking at here is a series of ordered pairs or points on the graph, and that's the same thing as the tables that you're looking at. Each point has an x and y value, just like each row in the tables on the left-hand side has an x and y value. Does that make sense?
Yeah.
Okay, so we're really looking at the same kind of information in a different way, and we just need to know each time that there's an x value, like with 1 and 2 or 2 and 4 or 3 and 6, what are we multiplying x by in order to get y? So what are your thoughts?
2 looks like.
Good. And did you use your trick again by looking at the value where x is equal to 1?
Yep.
Yep. So 1 and 2 is a good place to find the constant of proportionality. And it also looks like 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So it all seems to work. Down here we still have that 0, 0 point. It's not labeled, but it's still there just like the points were over here in the table in those relationships. So a proportional relationship, which is where this constant of proportionality makes sense, always is a series of points that will line up in a line that also goes through the origin. So that's another good thing to know. And so we can write here, what was the constant of proportionality again for this graph?
2.
2, so we can write that. And now let's ask a question we should always ask ourselves, which is, why should we care about this? Well, the good thing is when you have a relationship like this where you're multiplying x by something to get y, you can think about it as an equation also. So k is that constant of proportionality. You're multiplying it by x, so k times x or kx is always going to equal y. Does that make sense?
Yeah.
And then there's another way to think about this with just another letter. Sometimes that letter is put in as m instead of k. And that m tells you so much about how those points line up in a line. And that's the start of understanding equations for lines. And that's why this is so important.
Okay.
Make sense?
Yeah.
Okay, good job.